Hi everyone. Welcome to the first episode of this channel that looks at and gives you a basic rundown of what you are looking at. Today we're looking at Messier's catalogue first object, M1. The Crab Nebula, catalogue designations M1, NGC 1952, Taurus A, is a supernova remnant and pulsar wind nebula in the constellation of Taurus. The name comes from a drawing that somewhat resembled a crab with arms produced by William Parsons, 3rd Earl of Ross, in 1842 or 1843 using a 36-inch, 91 centimeters, telescope. The nebula lies in the Perseus arm of the Milky Way galaxy, at a distance of about 2.0 kiloparsecs, 6,500 light-years, from Earth. At the center of the nebula lies the Crab pulsar, a neutron star 28 to 30 kilometers, 17 to 19 miles, across with a spin rate of 30.2 times per second, which emits pulses of radiation from gamma rays to radio waves. The earliest recorded documentation of observation of astronomical object SN 1054, when a star at that location went supernova. In the 1960s, because of the prediction and discovery of pulsars, the Crab Nebula again became a major center of interest. It was then that Franco Pacini predicted the existence of the Crab pulsar for the first time, which would explain the brightness of the cloud. The star was discovered shortly afterwards in 1968 by Dr. Susan Jocelyn Bell. The discovery of the Crab pulsar, and the knowledge of its exact age, almost to the day, allows for the verification of basic physical properties of these objects, such as characteristic age and spin-down luminosity. The star that exploded as a supernova is referred to as the supernova's progenitor star. Two types of stars explode as supernovae, white dwarfs and massive stars. In the so-called Type 1a supernovae, gas is falling onto a dead white dwarf raise its mass until it nears a critical level, resulting in a runaway nuclear fusion explosion that obliterates the star. But in Type 2 supernovae, the progenitor star is a massive star whose core runs out of fuel to power its nuclear fusion reactions and collapses in on itself, releasing gravitational potential energy in a form that blows away the star's outer layers. Type 1 supernovae do not produce pulsars, so the pulsar in the Crab Nebula shows it must have formed in a core-collapse supernova. Theoretical models of supernova explosions suggest that the star that exploded to produce the Crab Nebula must have had a mass of between 9 and 11 solar mass. So 9 to 11 times more massive than our Sun. Most pictures of the nebula that you'll see on the internet or in books are composites. To form a single image, it's necessary to take multiple pictures of different parts of the specters. But what you have been looking is a visible light picture taken from my backyard. While the light pollution and resolution of my equipment may make it seem granular, it's essentially what you see as you approach the nebula. Assuming you could travel the 6,500 light-years. I hope you enjoyed this short video. If you want to see more like them, just click on the blue thumbs up. Please subscribe and share. Thank you and I'll see you soon.